What is going on, ladies and gentlemen? It's your boy Turbo13 bringing you guys a Black Ops 2 gameplay commentary. This really has nothing to do about the gameplay. I will mention this is a hard-fought, hard-point match on Nuketown, and I hate Nuketown. But anyways, let's get on to the topic at hand. And for today, it is going to be about the universe. And this is something that I can just spend a good amount of time thinking about it because it blows my mind every time I think about it. And hopefully you guys will feel the same way. You'll realize how really just spectacular the universe is, or at least the part I'm going to talk about today. And I'm really only going to be covering like mainly one subject, and that is just the sheer size of the universe. I feel like a lot of people cannot really wrap their head around this, and it is amazing. Okay, so I'm going to first of all start off by just saying that the universe is probably a lot bigger than you think it is. But let's go ahead and just start off with the Earth. How big is the Earth? The Earth's radius is approximately 6,300 kilometers, and that would make the area of the Earth about 500 million kilometers squared. And so that's pretty big. But then you start thinking about the other things, like the sun. Because our Earth is puny compared to the sun. The sun is approximately 100 times greater in size, or at least radius-wise, compared to the Earth. And with this, you're pretty much saying you could fit about 1,000,000 Earths into the sun, volume-wise. So we're saying that if we filled up the Earth with liquid and poured that liquid into the sun, you would have to do it about 1,000,000 times. And sometimes just picturing that gets ridiculous, because every time you see the sun in the sky, you know, it's not that big. But this thing is ginormous. But the sun is actually pretty small compared to other stars out there, like Betelgeuse, which is about 936 times larger than the sun, or at least radius-wise. And that's not even the largest star known to man. There are some bigger ones, but let's go ahead and go back to the sun and talk about that. So we're gonna go ahead and just say we scale down the sun to about the size of a grapefruit. That would make the Earth about the size of a small marble. Now, the sun to the Earth distance would be about 15 meters, and from the sun to the edge of our solar system would be about 600 meters, which anyone could easily walk in a matter of minutes, or sprint pretty quickly as well. But now if you try and travel from the sun to the nearest star, it's gonna take a little bit longer. From the sun to the nearest star on this scale would be like traveling across the United States, or about 2,300 miles roughly. And this just kind of makes you question really just how big is the universe. And the universe is a lot bigger than you think it is, like I said earlier. And this comparison is one of my favorites. It's just mind-boggling. Like, on this scale, going from the sun to the Earth is 15 meters. No big deal. That's just a couple of steps. Going from the sun to the nearest star is 2,300 miles. That is ridiculous and just mind-blowing. And just to think, the universe is constantly expanding, or at least that is what these scientists have concluded based on the evidence that they have so far. And the evidence that they have for that is the Doppler shift. They have the red shift, blue shift, and what they noticed is that the other planets, galaxies, and suns or stars are moving away faster and faster, so that's accelerating. And one great way for you guys to actually test out the Doppler shift, I don't recommend it because it's not safe. I have done it, and you might want to make sure that the road is clear, but get a friend in a car, and you stand just outside, a good distance away. He starts driving towards you, and as he's getting near, he starts honking his horn. He just holds it, and you will notice the frequency of the horn get higher as he's going faster and faster and getting closer. And as soon as he goes by you, the frequency drops, and it will get lower and lower the further he goes away. And that is really just a fun experiment. I've actually done that one myself, and it's very noticeable. Not really safe though. We did that one time, and my friend almost crashed on the street. It was a little bit too close for comfort, but just be safe if you are going to try that. But now let's give you the real size. Okay, so the nearest nearest star to our sun is about 4.6 light years away. And if you guys don't know, light year is a way of telling distance, measuring distance. That's what the astronomers use because the universe is huge, and using kilometers and miles would just be big numbers. So they use light years, and that light year is just really how far light can travel in 1 year, and that's pretty far considering that the light travels at 300,000 kilometers per second. So I'm gonna go ahead and write those numbers down for you guys real quick so you can see how far it travels in a year. Oh, and just a quick tip, if you are taking a physics class or you're going to take physics class and you have to calculate the velocity of something, if you ever get something faster than 300,000 kilometers per second, you did it wrong and you should probably recalculate. But anyways, back to talking about how far light gets in a year. So if we make the speed of light 300,000 kilometers per second, the distance traveled by the light per year is going to equal about, I think that's 9,460 billion 800 million kilometers, and that's just a rough estimate. And, there's more specific rounding and stuff, but that is just insane. So it's 4 times that. No, 4.6 is more approximate number. Times that is the nearest star to the sun. Just think about that distance. Just think about it for a little bit. Just let that sink in. That is far, and that is why living, or our generation ever going to live on another habitable planet, will never happen unless we can somehow travel at warp speed or something. If we can make some sort of a wormhole, we will never be able to live on another planet. We're gonna have to make rockets. So this is gonna have to be in the future. We're gonna have to make rockets capable of traveling near the speed of light, and it's gonna have to be able to sustain life for several generations before we can even get close to the nearest habitable planet. And so just the sheer size of all of this is insane, and the fact that it is constantly expanding is even crazier. Oh, and just think about the size of our galaxy alone. It is 100,000 light years across. Now, 100,000 times the, 9,460 billion number that we got earlier, kilometers wise, and then how far other galaxies are and how far other stars. I mean, that star is the closest star to us. There are stars and galaxies way further out there that we will never even get close to, and the fact that they're constantly expanding or getting away from us, and the universe is just scary. It is mind-boggling. It is fascinating, and I love it. And hopefully, you guys enjoy this commentary. I think in the next one, if you guys want, I will try to explain the Big Bang theory in a better sense for you guys. I know a lot of you guys don't know much about it. I have a little bit more knowledge than the common person, and if you guys want to see that, let me know in the comments below. But this has been Terrapro13. Hopefully you guys enjoyed this video like I did, and I'll see you guys later. Peace.
Securing B. Kill confirmed. Securing Bravo. Be advised, hostile